Unit 6.6, Day 2, Exponential and Logarithmic Equations. Today we're going to solve exponential equations. An exponential equation is an equation containing one or more expressions that have a variable as an exponent. So this is the inverse of what we do with logarithms. If b raised to the x power is equal to b raised to the y power, then we can say that x is equal to y as long as b does not equal 0 and b does not equal 1. Example 1 says solve and check. We have 8 raised to the x power is equal to 2 raised to the x plus 6. We want to rewrite, if we can, with the same base. So I ask myself, is 2 raised to a power equal to 8? 2 raised to the third power is equal to 8. So I first want to rewrite my base. Power to a power, I know I multiply this 3 and this x. Now my bases are the same, so I can take my exponents and set them equal to each other. Inverse of a positive x is a negative x. Divide by 2, so I get x is equal to 3. And I just solved the exponential equation. In example 2, I asked myself, can I rewrite 18 as 3 to some power? Well, that doesn't work. So then what I want to do is I want to rewrite this in logarithmic form. So I say log with a base 3 of 18 is equal to x. I then can use my change of base and rewrite this using log of 18 with a common log of 10 and divide it by log, common log of 10, of 3. And when I type this into my calculator using my log button, you notice I take my larger number in size, not in quantity. It's always going to be this number divided by this small base down here. So in the calculator, I get approximately 2.63. When I look at example 3, I have 5 raised to the x minus 2 is equal to 200. So the first thing I want to do is 5 to what power equals 200? None. So I'm going to rewrite it as a log. Log with a base 5 of 200 is equal to x minus 2. I can then do a variety of different things, but I'm going to go with the change of base. So I'm going to do log of 200 divided by the log of 5. I know I can add my 2 to get x by itself. So in my calculator, if I type log of 200, close my parentheses, divided by log of 5, add my 2, I can know that x is equal to 5.29, about 5.29. Looking at example 4, the first thing I want to try to redo is rewrite. 3 to what power is 81? Well, 3 to the 4th power is 81. So I have made my bases the same. I have x minus 1 on the left, 4 times the quantity of x plus 2 on the right. Distribute, I get 4x plus 8. Combine my like terms using inverse properties. Negative 9 is equal to 3x, divide by my 3, and I get x is equal to negative 3.